Hello, everyone. This is Belinda Carr. Welcome back to the Movers and Breakers podcast, where we dive into the world of construction and explore the stories of people and companies who are shaping the future of our industry. From the latest innovations to the challenges and triumphs of everyday professionals, we bring you the inside scoop of what's happening in construction. Today, I'm speaking with Gregory Siener, CEO of Plastikblok and Lok-N-Blok. Thanks for joining us, Greg.
Thank you for having me. I appreciate it.
I've been waiting to talk to you for a while. We first spoke a couple of months ago, maybe it was a year ago. But before we even spoke, I came across your product, the Lok-N-Blok plastic blocks, I think like 2 years ago or 3 years ago when I was first looking into the future of construction and alternative building materials. And I was fascinated by it, but I just couldn't get enough information on it. So I've been waiting for this podcast for a while. Thank you for sending me the samples. I appreciate it. Before we dive into the specifics of the block, you have an incredible story. It's a story I really admire. It's a story that I'd love to share with our audience. It has taken you almost 30 years to build this and to scale up production. What happened? How did you get to this point?
It is a long story. It's been a tedious journey, but an enjoyable one. We look at it from the standpoint that all the delays that we encountered gave us an opportunity to ensure that we had a refined product whenever we came to market. But our journey began in 96, actually. So 24 years, 23 years. My business partner and I were building a retaining wall, and we were joking around about the fact that as we were lifting railroad ties into place, putting them down into steel beams, I said, if we had some big old Legos, this job would just go a whole lot easier. We both laughed about it. We both joked about it a little bit, but through the evening and through the next day, that weighed on me. And I thought, why couldn't we have some sort of a big block like that? And so I began drawing, I began sketching, and just trying to come up with something that I thought would be an overgrown Lego. And we don't like to use that term. We don't like to step on the toes of a child's building block out there. But we were trying to come up with a stackable block that could be used, but we wanted to add a feature to it to interlock it end to end to make it stronger. And thus the original idea was conceived. I drew it out on paper, and at the time, my brother and I were partners in an electrical engineering firm. And, back in the days of faxes, I drew it out on a piece of paper and I faxed it to my brother, and I said, hey, take a look at this. And if you would, drop it into AutoCAD and let's play around with it. Let's see what we can do to build with it. And of course, you can input the properties of your material into it and do some testing, just some preliminary testing. And we came up with the idea of doing an injection molded product, more solid in nature, very similar to the sample there. Our first design actually had round posts instead of square. There was only 2 posts on the top, one at each end. So the design has changed from what the original design was, but the overall concept of a stackable interlocking building block is the same. It just, as we progressed, as we began looking at tooling, as we began looking at tooling design, as we started talking about material properties for actual composites that we'd use to inject the product, it took us probably 10 years to get to the point that we felt like we were comfortable enough to patent it. So we just casually developed for about 8 years before we enlisted a patent attorney. But even even he had some suggestions to our original design that we incorporated into the block, and we filed for our first patent in 2007. We didn't receive that first patent until 2010. It even took the patent office a long time to
Approve that. Why is
approve.
that?
And it wasn't so much that they were having difficulty approving the product for its uniqueness, but patent attorneys are also engineers. And as the engineer side of our patent reviewer continued to look at our block design, he kept telling us there wasn't room for rebar and concrete inside the block. And we kept responding to him that we're not using rebar and concrete. Well, according to his instruction, his education and training, he kept telling us that we couldn't use it. So it took a physical trip to the patent office with my patent attorney to sit down across the desk from our reviewer and said, your objective here is to tell us whether it's unique, not whether it's usable. That's our job. And, is it unique? And he said, oh, it certainly is. And he said, great, then let's walk out of here with the patent.
Wow.
So it was a long journey. And like I said, we went through, I think the tool that we're on right now is about the 27th design change that we made from what that original product was designed as. We've had many engineers touch it along the way. As we were going through that preliminary engineering period, we brought in different people that had different, one was a materials expert and made some changes to our tool based on the material that we intended to use. Another was a process expert, making some changes to our tooling based on the best process to use in the injection molding process. So we had a lot of sets of eyes, a lot of engineers, a lot of people looking at it that helped us along the way. We fortunately met a man who was in the plastics industry. He owned a facility located a little 20 miles away from Paducah, but he was a wealth of information, and he was old school. So we could sit down with one another, and he would share ideas that he had, and if we would do this or if we would change this, it would make it easier to sell, easier to manufacture.
From a plastics background, he gave you advice from that. Got it.
Correct.
Okay.
I was raised in the construction industry. My father he worked for a large volume builder out of Chicago, and all his brothers were involved in construction. I was raised around it. Summers working with my father. That was just what we did. It was a kind of a family thing. So
I have to ask you, do you think that your idea was so novel, so maybe ahead of its time, that's why people were slow to accept it? You think that if you had come up with this idea in today's world, in today's environment, there would be faster adoption, or you would be able to get the patent faster and everything would be much faster?
I certainly believe that. And even today, it's still hitting a great deal of resistance with the fact that it's a composite-based material, the fact that we are changing. We've created a whole new category of building and construction, structural building with composite materials. So people are still, I don't want to say slow to grasp the concept, but the first question we get asked is, I'd like to see a house. Is there a house near me that has been built with it? And the interesting thing is that if you're driving down the street, you would know our house from another house because you side it the same way or clad it on the exterior the same way as you would clad a wood frame or a ICF or a concrete block. Your exterior is going to be clad with a finishing material, so you would never know.
Yeah. I guess that's the good and the bad thing. And I mean, from an aesthetic standpoint, people wouldn't know, so they might accept it. But from another standpoint, people may not get as excited about the product because they can't see it. It's not visually present on a house. So what's the benefit to them? And the other thing I'm thinking of is that, like you said, you've invented a whole new category of structural building materials, and there's a lot more at stake to this than if this was just merely interior siding with just aesthetic purposes and no structural purposes. So I'm sure people are concerned about, oh, is it really as strong as concrete? If you don't have, like you said, the patent officer was concerned about rebar and how does it compare to concrete? Can I really trust this material? No, I want someone else to be the guinea pig before me. So
Right.
it's not just like an aesthetic material. You're actually changing how a house is built. So there's a lot more at stake.
You've hit on something that we as a company made a decision back in 2014 after we finally got our patent and built our first prototype tool and began our first production process. We knew that we were going to have to bring this to market through extensive external testing.
Yeah.
The International Code Council requires third-party testing on any approved product. We partnered ourselves with one of the leading firms in the United States when it comes to testing and forensic analysis of structures and buildings. Our firm is Wisjani Elsner, based out of Chicago. And like I said, they're one of the leading firms when it comes to testing and forensic analysis of structures. We knew that partnering with them through the testing phase of this would give us substantive concrete results that when we walk into an engineer or an architect or a builder and hand them our design guide with Wisjani's name on the cover of it, there's some credibility there that somebody of that caliber has reviewed this and endorses the quality and the strength of the product.
Yeah, it just calms them. They're not as concerned about the product. Yeah.
It's not just our opinion that it's good.
Exactly.
It's a independent lab's opinion that this is very substantial, very strong. And the unique thing about it, you've been talking about its strength compared to concrete, the fact that we are a composite, the fact that we have the flexibility, the flexibility is the best way to describe it, that we can release energy. We can bend a little bit and release energy without failing. So from a pure compressive strength standpoint, we're 5 times that of a concrete block for design loads.
Oh, wow.
From a seismic standpoint, we actually tore up the test frame that our lab used to test other products with, because we just didn't fail. As they began to load the wall, it just continued to receive the energy and release it, and receive it, release it, and you go through a cyclic testing.
And is that because of the design? I'm sorry, I didn't mean to interrupt you, but is that because of the design of the block, or is it the material? And for people who haven't heard of the block is actually made of polypropylene, a plastic.
It's both. It's design and material, but our material is polypropylene. It's a composite made up of several natural minerals, glass fibers. Polypropylene is our base polymer in it, and 49% of that is recycled.
Oh, wow. I saw on your website it was 30%. You've managed to raise it up to 49. That's awesome.
We're continuing to do things to try and increase our recycled content. We're at 49% recycled content right now. All other advantage is that we are 100% recyclable. We're talking with the manufacturers that we're working with now to produce our product. We actually take scrap product or tails, so to speak. It's the little piece that you break off after the injection, or any scrap parts or any purge. We can grind that down and we can put it right back into the process. But on a construction site, when a contractor builds and he has to cut a block in half or trim it in some way, we actually will buy that material back because we can grind that down and put it back into our process. We can recycle that material.
And not just recycle it as aggregate, recycle it as a structural building block. That's
Correct.
what's different. Like with concrete, I've seen people, if there are cutoffs and waste, it's just recycled as aggregate. And
Right.
this is very different. That's awesome.
Ours goes directly back into our product. But additionally, the third thing is we're 100% repurposable. Our block's integrity doesn't change in any way when you build with it. If you ever deconstruct a home, or if you ever end of use for a structure, a warehouse, a commercial building, where its end of life is there, you can deconstruct the building and repurpose those blocks into another structure.
Another structure.
Makes it ideal for temporary housing. When you think of hurricanes, when you think of, I mean, just this past weekend, the devastation in Mississippi,
Yes.
where you could go in and build temporary structures for people to live in while things are being cleaned up and prepared for rebuild. But then those blocks could be taken down from the temporary structure and converted into long-term permanent housing. Hurricane situations, Southern Florida, places along the coast, same thing, where you could walk in and set up temporary homes. I mean, right now, Red Cross moves into an area and they pass out 10 by 10 tents. This is much more stable and secure than a canvas tent would be.
The setup time might be a little longer, but it is more, like you said, stable, because it's a building block, not just a sheet of plastic.
Exactly. And you've got something that your investment in that tent goes away at the end of that disaster. The tents get burned.
Yes.
Or scrapped. Our product would be deconstructed and converted to another use. It would be used for another building or used for a home. And so there's a lot of advantages in our product that we don't even sell on. It's not a selling point for us, but the advantage is there.
Like inherent benefits, yeah. So let's give people a little visual idea of what the physical characteristics of this block is. I don't want to talk about Legos, but basically this concept is similar. They are stacking blocks with a male and female part that interlock in both the z-axis and even the y-axis, right? And you even have these grooves on the block which allows different blocks to slot into each other.
Mm-hmm.
And you don't need any cement, any rebar, which is why you can deconstruct them and use them on a different project.
Correct. Now, in saying rebar, we do use a post-tensioning rod, a 5/8 threaded rod that runs from the concrete slab or the concrete footer up through the wall to the top of the wall. And then you tighten that down, and we use a post-compression spring that we put on top of the wall. But that assembly together holds the wall. It's your tie down to your footer or your slab. So there is some steel in it. It's not rebar, it's not concrete, but we do have steel involved. But those are the two components of our system, the block and the post-tensioning rod. Post-tensioning rods run every 5 feet around your perimeter at every corner and next to every window and door. So there is some additional material, just the block itself, but there are no bond beams, there are no corner blocks, there are no half blocks, there are no end blocks. Everything is in the single block. When you make your corner, that the interlocking dovetails that are at the end of the block, they connect into the side of the block to make your 90-degree corner. So everything that you need to do to a block, or as you're constructing a wall, if you get to a rough opening for a window or door, you simply cut the block wherever you need to leave that rough opening. It doesn't change its structural integrity in any way, and allows you have a structurally sound wall when you make those cuts. But going over windows and doors, because of the interlocking nature end to end as well as top to bottom, you end up with a strong, so you can go up to a 6-foot distance without a bond beam across your windows and door openings. And once you get over 6 feet, then we actually have some details in our catalog that show how to you're basically, you put a steel channel below it and pull that wall together with the close tensioning rods to cross that span, to cross that opening. So it's a very simple system, the way it locks together, and it only goes together one way. You
can't mess that up.
dovetails are tapered, so they only go together one way. It makes it takes some of the skill required, some of the skilled labor issues that contractors face every day, and removes that. So a builder or a contractor, when he's having problems finding enough skilled labor for his job site, by removing that level of skilled labor out of the construction process with our product, it broadens your labor pool for the people available to build with.
It seems so too good to be true. You have thought of so many details. Like you said, you're on like the 27th iteration or something of this design. You've thought about, like you said, the dovetail joints and how people could mess this up, try to avoid any possible concerns with this. Has the block been approved for construction in the States? And why hasn't it been approved if it hasn't?
We have applied right now to multiple states. Most of them are waiting on our home state, Kentucky. We applied to them first, but a lot of states are reciprocal with one another. So once you gain your notice of approval for one, then you move to the others. We had not conducted our seismic tests when we applied to the state of Kentucky. So we got through the review process, and they said, we need to know how you stand up to seismic. There's 11 counties in Kentucky that are on the New Madrid fault line. So we had to have a seismic rating. So we conducted those seismic tests, and Wish-Janney issued the opinion letter. And we are waiting now on the data report of all the data points that we monitored during the test, to show the actual data behind the opinion. We meet all seismic categories A through E. So
have you actually built a house in the meantime to show people that it does work, or show the officials that it does work?
We have built one, but we've torn it down. We built it and deconstructed it. We actually conducted our tests. A lot of our tests were conducted with a test house that we built in the lab, a 1,200 square foot home.
Wow. And but that wasn't out on site. You said it was in controlled conditions.
It was in a lab. That way we monitored several things. We monitored loads. We monitored deflection. We had hundreds of data points that we were collecting as we built this structure. In addition to our live loading and compressive loading, we were looking at creep. We were looking at shear. We were measuring a lot of things through this test structure to get data to support all of our other tests that we were conducting. So yes, we built it, but in most local codes, until we get our notice of approval, most local codes won't allow you to build until we get that approval.
But you do have some exciting news. You're not waiting for the U.S. to approve it. You have some pretty exciting news to share with us.
We are not approved in the U.S., but we are approved in 11 countries outside the U.S. And Central and South America have embraced what we're doing. And that's primarily where our focus has been, through a partner that we have on a global level that is promoting our product through their work that they're doing with other governments already. So we've gained a lot of traction in several areas outside the U.S. We are looking at building our first plant outside the U.S. in Peru. Even this morning, our partner that we work with, Inti Global, Peru, Brazil, Dominican Republic, Guatemala, Honduras, Venezuela, several countries that absolutely love what we're doing and embrace what we've come up with. Peru in particular, but this applies to many other countries around the world. Water's a precious commodity for them.
Okay.
And the fact that our construction process, where their typical construction process is either poured concrete or concrete block, uses a lot of water. Ours uses none. So that is what initially
That was
brought
the main
us into
selling
Peru.
point to them. Yeah.
But as they've studied our product and as we've gone through the approval process there for our product,
They've seen all the other benefits too.
all the other benefits are coming into play. But that was the original selling point there. And it was something that we never designed into it. I mean, we never sat back and said, we're going to remove water out of the construction process. We didn't think about that. In America, we take that for granted. Yeah. We have a job site, and that's one of the first things put in. You put a temporary power pole in, and you drop a water line in, and it's just second nature for builders and developers here in the U.S. What we don't think is other countries. Yeah, Africa, same thing. We're getting a lot of interest in Northern Africa. And that's one of the reasons that we're getting the interest is we don't require water for our construction process.
In terms of price, I know it's different when you actually scale up production, but right now, how does the price of this block compare to a CMU block?
If you compare just the cost of the block per block, we're more expensive. But what we encourage people and what we do on our website is if you look at the square footage of wall area that you're building, putting the same R factor on that wall, bringing it to an R20, and making that wall ready for interior and exterior cladding. In other words, having the wall in a position ready for the sheetrock and ready for the siding or brick or whatever you're putting on the outside. We're actually comparable with 2x4 frame construction. So concrete block construction, we're going to be a little bit more expensive than, but because of the extra furring, because of the extra work that you have to do to a concrete block wall to be able to put sheetrock on the inside, for those areas where they're just building a concrete block home and they're putting stucco on the inside, we're going to be more expensive. For those areas where you're furring out and actually insulating and putting sheetrock on the inside, we're actually going to be less expensive than those areas. So we have a cost calculator on our website that shows cost comparisons to many other products. And we're trying to, just recently, we have to clarify some things on the website. We want people to understand that's not the square footage of the home, but the square footage of the wall area. So if you have a wall that's 10 feet long and 8 feet high, you're looking at an 80 square foot wall.
Think vertical, not horizontal.
Yeah. And so, making the comparison. So it's not particularly on square footage of floor area. It's the square footage of the actual surface area of the wall that you're trying to make comparisons to. And we use national standards for that. We use RS means to make those comparative tables for the website. But what we've done is we've been able to create a product that in your finished product, we're in the market. We're competitive with other forms of construction. So you're not paying a premium price for our product, but yet you're getting a product that meets all seismic categories without any additional materials. You're getting a product that meets 250 mile an hour winds without doing anything else to it, nothing special. You have a wall strength, a compressive strength in that wall that's higher than poured concrete.
Wow. I'm definitely going to have to dive into some more details on a dedicated video on Lok-N-Blok. But I have to ask you, when you started this journey, did you think that it was going to be almost 3 decades long? And it must have taken a toll on you, because I'm sure you were passionate about it, and obviously you believed in the potential of the idea and the product, but that's not an easy journey to go on.
No, it's not. At first we didn't think it would take that long, but as I said, we went through a lot of years of just preliminary engineering. And as I said earlier, my brother and I, we owned our own engineering firm, and we were, I don't want to say it was a pastime, but it was something that in between jobs, when we had spare time, is when we dedicated time to this. We didn't devote our full-time effort to it. It wasn't until 2013 that I lost my brother.
I'm sorry.
And it
I'm
just
so
we
sorry.
closed the company,
Yeah.
and I closed the engineering firm down, and I thought this is the time that I need to get Lok-N-Blok off the ground. You
I
know, if
bet it feels satisfying now to see things finally happen, and because this is a labor of love, and you to see it come to fruition after all this time must be you must feel really good about yourself.
I feel really good about what we've done,
Yeah.
and even more so than just creating the product that we created. I had recently some investors that we have involved in the project. He made a comment to me that about 6 months ago that I had never really thought of. But this investor, he's actually involved in the UN Council on Relief, where they're providing housing in countries all around the world. And during a lunch one day, he said, "You realize the product that you created has the ability to touch every single human being in the world. And we never developed it from a humanitarian aspect. We never developed it with anything in mind other than just a simpler way to build, a faster, simpler way to build that people that were do-it-yourselfers could use to build with and have something substantial when they're finished." In listening to him talk and in him sharing his vision of being involved in my project is that, this has the ability to house people that have never had houses. And he said it makes it real easy for countries that have housing issues to be able to provide product, even if the individuals want to build their own home. It at least gives them something to have a substantial home. And homes compared to what we have here in the U.S.
Yes.
are substantially different. But again, we had never thought about the humanitarian aspect of
Yeah.
what we're doing, which has made this coming to fruition even more fulfilling in that we're doing something that has value to it. We're not just introducing a new building product. We're not just enabling people to build here in the U.S. We're doing something that can reach out and touch people.
It's almost like it's not a one-to-one analogy, but it's like projects from the Roman times or the Greek times. It was a multi-generational project. They had a vision for it, but a particular person who started it didn't see it come to that full potential during their generation. This could change our industry. 3 generations from now, everyone might be switching to this. We don't know. And especially with all this legitimate concern for the amount of plastic waste and all, we don't know. In another generation, they might be able to might be able to be made out of 100% recycled plastic material and no virgin plastic. And the potential of this block is enormous. You've created something really, really special, and I'm glad to see the momentum picking up and the wheels spinning, and I can't wait for it to actually be cleared for use in the U.S.
Well, and you mentioned the 100% recycled plastic. Keeping in mind, polypropylene is actually made from the byproduct of the oil refining industry. So
Yep.
we're using in essence, it is 100% recycled from the standpoint that we're using a byproduct. Our polypropylene is a byproduct anyway.
That's true.
So, the fact that we're using polypropylene and 49% of it is recycled polypropylene, it makes it even greener. It makes it an even less impactful. That
terms of energy.
polypropylene would be used by somebody, but the whole reason we chose it to begin with is in 2007 when we were trying to choose a material to be our base polymer. Our focus was on green groups, and Greenpeace was kind of the leader in recycling and renewable energy efforts. And Greenpeace listed polypropylene as a green plastic.
Okay.
And so our decision was made early. We're going to use polypropylene, do to it whatever we need to do to it to make it strong and stable. But our whole effort from the beginning of material choice was to ensure that our carbon footprint was less, our material that we used. We wanted to do something that would not, even if it is recycled or taken to a landfill, if this is to be burned or incinerated, it lets off carbon dioxide and water vapor. There's no harmful chemicals that come out of polypropylene.
So like I said earlier, I'm going to have to make a separate video on this to dive into the details, because I'm sure people want to know a lot more about this product. But I was wondering if you could end the podcast with some advice for people who have a solid idea, passionate about something, but are facing a lot of resistance from the rest of the industry. What words of wisdom would you like to give to them?
First of all, ignore the people that are against it. We had a lot of people, and I'll go back to our plastics guy that helped us. He was such an enormous value to us at the beginning. But one of the things that struck me with him, every time I would meet with him, he would remind me, Greg, I don't have any issue. I know I could make this product for you. No matter what your material is, I know I could make it. I can make it consistently from one to next. I just don't know if people are going to accept it. I don't know if people are going to use it. And I can't make that happen for you. When we did our launch, our soft launch in 2013 with our first product, and it was kind of our go, no-go decision of, do we move forward with this? And we were at the International Builders Show in Las Vegas, and we probably had 50,000 people through our booth that week. It was unbelievable. But I invited this gentleman to come to the soft opening and be there for us those few days during the show. And the last day of the show, as we were walking out, he said, you probably remember what I tell you every time you leave my office. And I said, oh, I do. And he goes, I don't think that's the issue anymore. He goes, now I don't know if I could ever make enough to satisfy the demand that you're going to have. And I guess I had an individual from the plastics industry telling me that he doesn't know that anybody would ever buy it.
Yeah.
We had to push past that. We had to ignore the people that said it won't work or people will never use it, to get to the point where we have something that we know is stronger, more beneficial, safer, down to job site injuries. Yeah. 4 of our blocks weighs less than 1 lightweight concrete block. So, even if we cause a reduction in job site injuries, we're providing improvements in so many aspects of construction that if we had not pushed through and thought outside the box, this product wouldn't be here. I've had...
Don't take no for an answer.
Several people very near and dear to me say, when are you going to stop this idea and just move on and go find yourself a real job? And this has been my focus. I mean, this has been my life for the last 10 years, it has been my life.
What an amazing story to share. Thank you so much for giving us a peek into the story behind this product and the amount of work that's been put into it. And I'm sure your brother is very, very proud of what you've done and what you're going to do with the product. And it's going to turn out great. I'm sure about it.
Well, we have a lot of demand right now. As soon as we can get an approval from the state of Kentucky and from
come on, get going.
other areas, we're poised, ready to start production.
I hope that happens soon. But thank you so much, Gregory, for sharing the story with us. And you're welcome back on the podcast at any time.
Thank you. I appreciate the time.